Hello everyone. What we're going to talk about is removing fractions from an equation. And sometimes whenever there's a fraction in the equation, it causes people to worry. They automatically say, "Oh my goodness, I have to deal with fractions. How do I do this?" So, there is a very simple way to be able to remove a fraction. And first off, just reinforcing that fraction is nothing more than a division problem. It is comparing two things. It is comparing the parts to the whole. And to simply get rid of fractions, to make a fraction not a fraction anymore, what makes it a fraction is having that denominator, that divisor. So if we remove that, then it's no longer a fraction. And I'll show you how to do that. So we have two examples here. In the examples, it simply solve the equation. We need to find out what is the value of x in these equations. And we'll look at the first one. What I'm going to do is rewrite this. And I'm going to say 1 over 2. So 1/2 x is equal to 12. Now, if one of the things I always emphasize is to critically think and look at your problem, structure it, and ask yourself questions. And for this question, what it's simply saying is 1/2 of some number. So I'm taking half of something and it's going to equal 12. And with that, you should be able to reason through and say, oh, okay, I know the answer. I'm going to divide something in half and then it's going to equal 12. But mathematically, let's look at how we would do this. And this goes right back to one-step equations where we're multiplying and dividing. I need to get rid of that 2. 2 is, we could say, creating this fraction. So what I would do is I would simply multiply by 2. Any number I can make a fraction simply by placing it over 1. And now we're back to just multiplying fractions. What happens to our 2's? They cancel each other out. One is in the numerator, one is in the denominator. I did not have to write this as a fraction, but sometimes it's easier to visualize it. I can just simply write 2. 2 times 1/2 is 1. Remember, in math, whatever I do to one side of the equation, I have to do to the other. Same with fractions. If I do something to the numerator, I must do the same thing to the denominator. So with this, since I multiplied 2 by 2 on this side of the equation, I must multiply 2 by 2 on that side of the equation, and what I end up with is x equals 24. Okay, now that was a simple example, but you always pick a simple example to work, one that you can visualize. I'm going to take the same concept though and do it over here. Before I do that, pause the video, work this problem yourself, and let's see if we get the same answer. Alright, so I have two fractions in this equation. And you have to admit, this one's harder to be able to look at and say, what do I need? What will the answer of x be? And if you can see it, excellent. But we'll pretend that none of us can see it. And the problem in this equation are the fractions. You say, oh my goodness, how am I going to have to do math with fractions and everything else? Well, let's just get rid of the fractions. The first thing that we do is we look for a common denominator. And in this problem, we have it. We have a common denominator of 2. All of my fractions have 2 as the denominator. Those are the easiest ones to do. I simply need to multiply through this entire equation by 2. So let's rewrite this and highlight our denominators. And since they're both 2, if I just say I'm going to multiply everything by 2, what this turns out to be is 2. I'm going to distribute this 2 to each term inside of here. Distributive property. 2 times the negative 2x minus 2 times one half equals 2 times 7/2. 2 times a negative 2x will give me a negative 4x. I know that that's going to be negative. It's a negative 2 times 1/2, so minus, and then 2 times 1/2, well, my 2's cancel. That leaves me with 1 equals 2 times 7/2, well, my 2's cancel, and it leaves me with 7. You've just eliminated your fractions, and now you are down to a standard two-step equation. Add 1 to both sides, divide both sides by a negative 4. X equals a negative 2. Two more examples. We have to make them to where we get a little bit more advanced. So if you want, pause the video and see if you can work both of these problems and see if we get the same answer. Okay, on the last example I said if you have a common denominator, it's easy, just multiply it by that denominator, but here we do not have a common denominator. So what I find is the least common multiple. What number, the smallest number, it makes the math easier. Always dealing with smaller numbers makes it easier. What's the smallest number that I can multiply through by that will cancel out 4 and cancel out 2? Well, you can easily say 2 times 4 is 8, so I'll multiply through by 8. And that's going to give you larger numbers. The easiest number to say is if I multiply through by 4, because 4 will go into 4 one time, and 2 will go into 4 two times. So we're going to multiply through by 4 to everything. 3/4 x minus 1/2 equals 1. And that turns into 4 times 3/4 x minus 4 times 1/2 equals 4 times 1. 4 times 3/4, guess what? 4's cancel. I'm left with 3x. 4 times 1/2, well, 2 will go into 4 how many times? 2 times. That leaves a 2 there. And what does this 2 become? It becomes 1. Minus 2. 4 times 1 is 4. Add 2 to both sides. 3x equals 6. X equals 2. I could have chosen 8 and I would still get the same answer. My numbers would be bigger though. I'd have a little bit more math to do. Or you could say more complicated math. Because I am very good at multiplying by 1s and 2s. 3s get a little harder. 4s, you know, the bigger the number gets, it's the difficulty of doing the multiplication is there. So keep the numbers as small as possible. For this problem, the least common multiple, 40. 8 will go into 40 5 times. 4 will go into 40 10 times. 5 will go into 40 8 times. That's the smallest number. Now I could take these three and multiply them together, but then I'm going to end up, let's see, 160. And there's nothing wrong with that. You can work it both ways. Whenever you're done, you can multiply through, or after I finish this, or after you watch the video, you can multiply through by 160, and you'll see that you'll still get the same answer of x if you work it correctly. So what I'm going to multiply through is by 40. So I'm going to say 40 times 7/8 x plus 40 times 1/4 equals 40 times 3/5. This becomes a 5. That's gone. It's a 1. This becomes a 10. This becomes a 1. This becomes an 8. Becomes a 1. 5 times 7, 35x, plus 10, because 10 times 1. 8 times 3, 24. And then I subtract 10 from both sides. And then divide both sides by 35. And there is nothing wrong with getting an answer that does not turn out to be an integer. There's nothing wrong with having a fraction like this. Sometimes you get that answer and you think, oh my goodness, I've done something wrong. Part of you wants to say, oh no, I need to add 10 because then that's or I messed up in my math. These numbers should work out nice and smooth. Nope, sometimes that's what they do. The whole point is being able to work the steps. So, in each one of these problems, I hope that you see that, and let me illustrate this. That way you can, this was the least common multiple. Okay. The in finding that number that you multiply through by, I need to emphasize this again. And higher up maths that you get, they will simply say just multiply all three numbers together. You do not have to find that. I would not be able to multiply these three numbers together, 8, 4, and 5, and find 40. Sometimes it's just that you see the number. Okay? There is nothing wrong if I chose 160, and you can work that yourself to be able to work through. It's just that I'm going to have bigger numbers whenever I get down here to my two-step equation. That's it. It's kind of like taking a fraction and saying 1/2 equals 2/4, which equals 3/6, and then just jumping all the way up and saying which equals 50 over 100. What do all of these fractions equal? 1/2. I never changed what this equation equals. I just rewrote it by multiplying everything by the same number. Alright guys, so that is how to remove fractions from equations. Again, if you don't like that and you work it just with the equations, there's nothing wrong with that either. Okay, critically think and structure your homework, watch the publisher videos, and good luck with your remaining homework problems.